Despite the title, this is not going to be so much of an Elasticsearch talk, but more of a security and usability talk and what we do to keep Elasticsearch as secure as possible. If you have Elasticsearch questions which are specific, just like catch me on the hallway after the talk and I'm happy to answer anything I can. The main idea of this talk is that you probably start more thinking about your own applications and what you can do to properly secure them. Because Elasticsearch being a Java application, sometimes it looks like it's hard to interface with operating system features, and I want to show it's not. Yeah, about me, hi, I'm Alex. I work for Elastic. I've been there since 6 years. I'm a developer, and yeah, I hope to talk a bit about Elasticsearch here. Elastic itself is a company with about 1,000 employees. We are fully distributed across the world. I live in Munich. We have an office there. I never go there. I really enjoy doing home office. And Elastic itself is the company behind the Elastic Stack, being Elasticsearch, Logstash, Kibana, and Beats, plus a couple of commercial products on top of that, because it turns out with just open source products, you can't make any money. So, who of you knows Elasticsearch? Just a quick hands up. That's amazing. I only have this one slide with a couple of pieces on it, what it is. So Elasticsearch is basically a search engine allowing you to do classic full-text search or analytics, aggregations, or geo-based search, or all of this combined. And it's in real time. It's distributed and scalable, which basically means you can run it on one machine or on 100 machines. You, as a user, should not notice this. And it's highly available and resilient, which basically translates to a feature that if a node has an outage, you should not be required to invest any work in it. The cluster finds out about this itself and repairs itself. The interface to Elasticsearch is HTTP and JSON. The idea behind this is simple. Most of developers know either the object notation and the protocol, so it's pretty easy to communicate with Elasticsearch. Elasticsearch is basically the centerpiece of the Elastic Stack. It's the system that stores all the data, where all the queries get executed against. And my personal uneducated guess is there are tens of thousands of clusters running somewhere, which basically means there are hundreds of thousands of Elasticsearch instances running. This translates to one problem. It has quite a big attack surface, right? We can't have security as an afterthought because Elasticsearch is pretty much running in a lot of places, which means we have to think about security all the time, so you may need less to. So this is my idea for today. I want to talk about security in general. Is it a feature? Is it a non-functional requirement? I want to talk about the Java Security Manager in particular. I want to talk about something that we call production mode and development mode. I want to talk about plugins, and I want to talk about our scripting language and how or why we wrote it. Security first. Feature or non-functional requirement. If you see security as a non-functional requirement, everyone is like, yeah, your software has to be secure. That's a super obvious statement. If you ask different people inside of your company, one person is probably telling you, yeah, we can do defensive programming. The business guy is probably telling you, oh yeah, let's just not store specific data, so we get this PCI DSS certification, which is a smart idea. If you don't store credit card data, no one can steal it. The next one is going to tell you our software is not exploitable. Yeah, of course, I'm just not believing this case. The main issue here is if your software is not exploitable, the humans using it are. Imagine a call center and you find the one person who is revealing all the secrets. A lot of things have happened here on a technical perspective. Just take a look at Rust as a programming language compared to earlier. Other people are going to tell you security is sort of a feature or locking out things. I put this here as an unintended resource access because a couple of years ago there was a very famous CVE. CVE is a security database entry about a dishwasher by Siemens. And this dishwasher had a security bug that the web server running within this dishwasher had a directory traversal attack. And Siemens was super happy to claim that they fixed the bug, which still meant there's a web server running on your dishwasher, which may be the issue in the first case. So security just is a different point of view at some places. Of course, you always want to run in least privilege, so these is a couple of things you think about security as a non-functional requirement. Security as a feature is something which I don't want to talk about today, at least from an Elasticsearch perspective. Elasticsearch has a commercial extension for security, which deals with authentication, authorization, TLS, audit logging, and something like single sign-on, SAML, and Kerberos. These are all things for me where you sort of integrate into other things, where security is really a feature and you extend the product. It's not something like preventing directory traversal attacks or executing code, and this is what I want to talk about today. Also, security or resiliency can be super blurry. For example, take integrity checks. If you do checksumming in TLS to make sure that no one has tampered with your data, it's a security feature. If you do checksumming for your data which you have written to your hard disk, it's an integrity feature and not a security feature. So things are sometimes just very similar in nature, but different in what they're trying to achieve. Preventing an out-of-memory exception in Java, is this a resiliency feature or a security? It's hard to tell. It depends how or what exactly you're preventing. Preventing deep pagination in Elasticsearch is something I'm going to talk about later. But preventing deep pagination prevents running out of memory. So again, we don't know, is it a security feature if your service is still reachable, or is it a resiliency feature? Exposing credentials is a pretty easy one. This is more a security thing than a resiliency thing. Stop writing data before running out of disk space. It's not so much a security feature, but is your own product that you're developing taking care of this? Because many products just corrupt data when they're writing stuff like a B tree on disk. So you have to prevent this kind of things. Is your system resilient against someone calling system exit 0 in Java, which means exit JVM, which is a problem because suddenly your process is dead and is not doing any processing anymore. So, what I'm going to talk about. You may have heard this famous citation by Donald Rumsfeld, who was the Secretary of Defense when he made it, where he talked about the second Iraq War invasion. He was talking about known unknowns, known knowns, and unknown unknowns. And this kind of translates into security things. There are so-called known knowns, where you think, this is something we should take care of, we know about it, and we can fix it. Think about a file that stores credentials. You have to make sure that this file is not readable by anyone else on your system. This is things you can easily fix either with documentation, or you can fix it in your packaging process by assigning the right permissions to your product. Then there are known unknowns. For example, if your system is exploitable by any means, if someone manages to execute some code, you don't assume your system is super secure, so you have to assume that this can happen. But if you knew how this would happen, you would have prevented it already. So this is what I consider known unknown. Then we have the last category, the unknown unknowns. My prime example for this happened at the beginning of last year with the Spectre attacks. If you're an application level developer and someone is able to read off certain memory of your system, there's not much you can do. Like, this is a hardware issue and you have a very hard time fighting against this on a software level. All right. Let's talk about the Java security manager. Who of you is a Java person? Hands up. All right, who of you has ever executed this call in his Java program? Who of you has ever activated the Java security manager in any of your applications? Okay, this is great. No one raised their hands. I've given this talk a couple of times in front of Java user groups, dedicated JVM users. It's exactly the same result. So people are just not aware of the security manager. So what is it? It's basically a sandbox around your Java application. And it allows you to prevent certain calls by this application. Who of you has dealt with Java applets in their career? Okay, you're either very old or had this in university like I did. Java applets were way like 10, 12, 15 years ago, where you could download someone else's code and run it locally on your system, which is quite the security nightmare for anyone involved in it. But the idea of this obviously was that you could execute this code. And the Java people thought they were smart, and they set boundaries around this code execution. And this was the Java security manager with their sandbox. So what you basically could do is, before the Java application was started, you could configure a file, and you could say, the applet or the code running should only be able to read this file, should only be able to write this file, should not be able to open new connections to other hosts, should not be able to open up a server that listens on a port. So you could basically lock down your application and the application could not do anything about it. I mean, nowadays this is exactly what happens when you open up your browser and you visit a web page. All the JavaScript code is just executed within a sandbox. And the idea here was exactly the same a decade ago. So the drawback of the solution back then or nowadays is that you have to have hard-coded policies when you start up. You have this one configuration file, you set it up, and you have to make sure you code everything. By default, DNS lookups are cached. That doesn't sound much of a problem. DNS nowadays, most of the time, is still unencrypted. There are a couple of nice initiatives going on solving this. But this was considered a security issue. This is a problem if you're running in a cloud-based environment because IP addresses change all the time, and this means you need to restart your JVM in order to solve this issue. Also, the Java Security Manager forces you to think about your dependencies. Most of the people, they just take all their dependencies and end up with a super big archive of dependencies. But do you know which of your dependencies are actually using reflection? Like, you don't, because you rarely care. You don't need to care. If you use the Java Security Manager, you have to know what kind of permissions all of your dependencies actually require. And the other problem is that all of those dependencies I was just talking about, they also are never tested with the Security Manager enabled, right? Because no one apparently deals with it. When we added this to Elasticsearch, we had to fix Netty a lot in order to make it work with the Security Manager. This may also result in code paths being executed that are absolutely never executed when the developers of the library run this in CI. And that, of course, is a huge issue. Also, it's only a partial protection, right? You can protect opening or sending data over the network. You can protect reading files, but you still have like all the standard Java problems of still being able of running out of memory. If someone is able to create a Stack Overflow exception, your JVM will just exit. Those problems remain. And if you run Java agents, all bets are off anyway, because Java agents are initialized before your application is running. Okay, that was a quick introduction into the Java Security Manager. Keep that in mind. We're going to talk about that in a while later, how we integrated that in Elasticsearch. The next thing I want to talk about is less security, but more about usability. The talk had the title, like, making your search engine secure while maintaining usability. The whole idea of Elasticsearch is that it's super easy to get up and running. You should be able to download Elasticsearch on your notebook, start it, and from then on it should be just up and running and you can index data into it. On the other hand, we want to make sure that when you're running in production, your operating system and your JVM setup is as good as it can get, so that certain preconditions are met. So we have to find a way to basically run in production or have different checks in production than in development mode. There's a nice blog post which has the same title than the subtitle over here, Annoying You Now Instead of Devastating You Later, where we explain the whole rationale behind it if you want to read it. So yeah, this is kind of an obvious question. It's super unlikely that your development setup is equivalent to production. Otherwise, we would all be running MacBooks in production, which is not happening. So the main question here is, how can we, as Elasticsearch, check that we basically add a couple of checks when starting Elasticsearch up in production mode, but we don't do this if you run on a notebook? What can we do? Well, Elasticsearch is a distributed system. So we thought, we're smart. If you're running Elasticsearch on your notebook, then you're basically only running on localhost. So if you're running on localhost and you're not binding to a network interface, this must be some sort of development mode. But as soon as you're binding to a network interface and you're communicating over the network, which is not localhost, this is a production system. And we thought, this is a great idea, let's just implement that and see how it works. And of course, if you start Elasticsearch on your notebook, you fire it up, it's not running these checks. But if you, as soon as you assign a network interface, it is. Well, there's this little tiny thing. And Docker is basically nothing else than a software-defined network, which basically means even if you run a Docker instance locally on your notebook, you still have different IP addresses than localhost. And this means our check would fail, and you would need to configure the Docker container according to our production setup. So what did we do? We basically added a special option that you can run a single node instance, which will never form into a cluster within a Docker container. And this works as well and passes this or skips the checks. So what kind of checks am I talking about? And this again is one of the slides where I would like you to take a look at those things, because I think you can easily incorporate similar things into your own applications. So we have a definition called the Bootstrap check. And each of those Bootstrap checks you're seeing here is basically a check that a certain condition is fulfilled in order for Elasticsearch to operate at its best performance. So if you take a look, there's, for example, a file descriptor check. Elasticsearch is using Reelsen under the hood, which is the full-text search library. This full-text search library writes a lot of files, which means it needs a lot of file handles from the operating system. So if you use a standard distribution, you usually are only allowed to open 1024 files, for example, if you run Ubuntu. And this is not enough. So this Bootstrap checks controls how many files you can open in parallel as a user, and if it's not enough, Elasticsearch will not start. There are more of those checks. There's an mlock-all check. Mlock-all is short for memory locking. Memory locking is a feature from the operating system where the process can tell the operating system that it never ever wants to be swapped out. This is very important for Elasticsearch because as soon as you swap out Elasticsearch on disk, things like garbage collection can take ages. So this can happen, but on the other hand, if we have configured this, but the memory locking failed and the operating system tells the process that this didn't work because you didn't have enough permissions or anything, then we want to make sure that Elasticsearch doesn't start. There's one more check for the maximum file size. So if you have certain interesting file systems, it's mainly networked file systems, you may not be able to store a file bigger than 2 gigabytes in size. This is something we need to know about because Reelsen tries to write bigger files over time. The maximum number of operating system threads that you can open is limited by default, but Elasticsearch needs a lot of threads to actually operate. So these are all checks which are super vital for a production system in order to run smoothly. And we want to make sure you configured your system before you run into troubles when running in production. The checks on the right-hand side here are basically all about the JVM. We, for example, want to make sure that you don't use a certain version of the G1 garbage collector because it produces corrupt just-in-time compiled code, so corrupt bytecode. We also want to make sure that you don't use a serial garbage collector because Elasticsearch would be super slow with that. So there are a couple of things we just check on startup, how you configured the JVM, and if you've configured in the wrong way, again, Elasticsearch would just shut down. Okay, so those are the Bootstrap checks. The Bootstrap checks, again, are more a usability kind of thing, but for us, they are super, super important because only because of these Bootstrap checks, which are run on startup, we can basically be sure that the system is configured the way it is. The next thing I want to talk about is, like, again, a little bit back about security, is reducing impact. So what can we do that even if someone kind of punches through one of our security measures, we don't compromise the whole system? So what can we do? Of course, there are a couple of buzzwords which are always flying around, like there's the least privilege principle. It may potentially make a lot of sense to not run as root. You also want to prevent forking of processes. This is one of the major problems of many systems, that someone finds the ability to execute other programs, other processes. Someone finds the ability in a web application to run cat etc shadow, and he sees all the passwords of your users or anything like that. This only works because the application is allowed to fork other processes. If you can't fork other processes, this would not work. And once Elasticsearch is up and running, we don't really need to fork other processes, so we could just try and prevent it. Of course, you don't want to expose sensitive settings. We want to include the security manager. And this is basically all the code you need to check if you're running as root. Apparently, if you take a look at the top, it doesn't work under Windows. No, there's no reliable check to control this. But the second call in there is using a library called JNA, Java Native calls, to just call the system call get EUID, and if that one is returning 0, we throw an exception and we don't start Elasticsearch. So the code itself to check for this is super short. On the other hand, it's a bit of a lie because the Linux system, of course, is not checking if a UID is 0 for administrator privileges. The security system called capabilities within Linux, and just the user with the ID 0 has all these capabilities available. So if you would want to really solve it, you would have to check for those, but this is sufficient for 99.9% of the cases. All right, who of you has ever heard of Seccomp? Oh, as much as running with the security manager. All right, let's talk about Seccomp then. It's new and interesting for everyone. So, first things first, we always have to assume that one component from a security perspective can fail in our system, right? And we still want the whole system itself to be as secure as possible. And I just said the reason why we don't want Elasticsearch to be able to actually fork processes. We don't want someone to find a hole in our scripting engine, for example, and then run cat etc passvd. We don't want someone to fork a process that runs a so-called bind shell where you can send commands to as part of Elasticsearch. And of course, we could try to write all of these mechanisms ourselves and writing super fancy code to prevent this runtime exec calls in Java, but there's an easier way. Seccomp is a feature in the Linux kernel which basically allows a process to tell the operating system that whenever it tries to execute those system calls, the operating system simply rejects them. It's sort of a one-way operation. So the process starts up, is telling the operating system, look, if I ever in the future try to execute one of those system calls, just stop me. Just stop me, I don't want to do this. And this is exactly what we do in startup. And it's an interesting principle because this way the application can basically configure itself and can tell the operating system what it should do. So basically the child is telling the parent what it should not be doing. It apparently doesn't work at home with our daughter, but in IT security it works. So it's a great feature. The interesting part about Seccomp is it works with all operating systems. It has a different name in each of the operating systems. Of course, the implementation is slightly different as well, but the basic framework for this exists under Linux, under Windows, under Solaris and BSD, and OS X, which is just a BSD. So this feature has been there for ages. You can just use it. You just need to use it, or you want to use it. All right, the security manager. Elasticsearch is a bit different than a Java applet, which you probably have assumed. It's a server-based application. And Elasticsearch cannot just start with the security manager enabled by default. Because the first thing that Elasticsearch is doing is basically reading its configuration file, finding out where's my data path, where I need to write my data, where's my path, where I need to write my log files. So we have to get to a certain state first, and only then we can enable the security manager. Also, we have to execute all of this fancy native code first, right? Am I running as root, setting up the Seccomp stuff? And only if all of this is done, if we basically have finished a certain kind of Bootstrap action, we can start the security manager. And that's a good thing. We can do exactly that. You can start a Java application with an empty security manager, then do all of your bootstrapping things, but before you're actually firing up your network-based code, you should make sure that the security manager is enabled, right? And this is exactly what we do in Elasticsearch. This also means we have a custom implementation of a security manager, but the nice part about this whole framework is all the functionality that the Java and the JVM is offering, it's super easy to extend. So you can just run your own custom security manager. For example, the default security manager allows you to call system exit, which means you can exit the JVM. And from an applet perspective, this makes sense, right? You're downloading someone else's code, running it locally, and if this someone else's code is calling system exit to shut down the JVM, it's great, because then it's not a security threat anymore. If someone is running my server-based application and finds a way to call system exit code, my service is not running anymore. So this is something I really want to prevent. I don't want anyone else to call this system exit except when I really want to shut down. Also, there's a certain security around threats and threat groups. So by default, you cannot just start a threat in Elasticsearch. You have to properly register it with the framework so we know the life cycle and we can get the stats. And you can also add your own custom permissions. So one of the permissions I talked about at the beginning was the ability to open a file for read or write operations. And you can also implement your own permissions. And we're going to see a couple of examples now. And yeah, the last thing you need is a so-called policy. The policy is, by default, this one configuration file where you set those different permissions. But the policy in Elasticsearch is a bit special because it contains all the information about the configuration files. So you would not need to write your own policy file. Elasticsearch takes care of everything. And there's also one of the fancy Bootstrap checks. So there's one special permission in the Java Security Manager, which allows you to do everything. So you basically disable the Security Manager by adding this permission. That sounds like a super stupid feature, but it is actually useful because it allows you to enable the Security Manager and basically see which code requires which permissions. So you have sort of a trace mode. But we don't want you ever to enable this. So we have a specific check to say, if you enable this, we bail and we exit Elasticsearch immediately, because you would just remove all the work we invested in improving security. So yeah, we're gonna skip the quiz question. The important part here is it took us a really long time to properly implement the security manager in Elasticsearch. And at first we added it, and we added an option to disable it, but at some point we decided we really want the security manager to be enabled, and I will get in a second to the reason why this was the case. And we really don't want anyone to disable it. So right now it's enabled by default. It works, you don't notice it at all. And I don't know any other big open source project which is actually running with the security manager enabled, which is kind of sad because I think it's a great feature. All right, plugins. Plugins are extensions to your code. Plugins are a security nightmare, right? Because you're creating hooks for someone else's code. You're basically allowing someone else's code to run in your product, and you still want to stay secure. It's kind of diametral requirements. It doesn't really work. So you can't solve this fully, but you can at least try to improve the situation. So plugins in Elasticsearch are just zip files in a certain structure. And each plugin can have its own jars and dependencies. So you can also have the same dependency in a different version in your plugin, and it doesn't interfere with the main Elasticsearch code. The main reason for this is that each plugin is loaded in isolation with its own class loader. That's the same mechanism that's at work when you, for example, have a Tomcat container, and you have different jars deployed in there, and they contain the same dependency information. The nice feature of this is that each plugin can also have its own security permissions. So maybe you need a certain permission for some of your code. Maybe you need reflection for your templating language. But this doesn't mean that any other code within Elasticsearch, any code that we wrote, should be able to use reflection. And this is something that you can have control over with this. And we also use this feature ourselves. So we basically modularized the Elasticsearch code. And a couple of those things are running as so-called modules, which are basically plugins that we ship with every Elasticsearch distribution. But they also run in isolation, because we have a couple of modules as well, which require reflection to be up and running. But we don't want all of our code to be able to use reflection. So this is basically how a permission file looks like. This is also how you would configure a Java applet with a certain permission file. And in this example, we are basically enabling reflection. And we're not big fans of it, because reflection allows you to change the state of variables on runtime. You can not only change the state, you can also change the type. You can also possibly change static final variables, which are not supposed to be changed, but it still works. So reflection is usually something you would like to stay away from if you want to have a secure system. But it's really, really hard, because many apps, especially web applications or libraries, require reflection. This is another example from a so-called custom scripting engine that we have, where we also add a pretty dangerous permission. We allow this plugin to create own custom class loaders, which basically means it could load arbitrary classes from within Elasticsearch or from within its own code. So we added another smaller permission, which is called the class permission here, that this code can only load the classes that we actually whitelisted. So we don't need to be afraid that someone is loading classes they are not supposed to be loading. And as you can see, the model allows easy extension of all of this. So pretty much no matter which use case you have, you can easily extend this whole security framework. You can also go more granular. In this example, you can allow permissions for certain jars or for certain dependencies. So what this basically means is that we are allowing the netty dependency to read and write on the network socket with the socket permission, but any other code, even within Elasticsearch, will not be able to open a network connection, only this one jar. And this means no matter if someone finds a way to execute code, as soon as this code would try to open a network connection, the security manager would say, oh no, I'm not allowed to do this, right? And this adds a huge layer of protection on top of your Java application for relatively few work once it's implemented. Okay, scripting. Scripting is very similar to plugins in a couple of things. One of the main things with scripting is usually that at some point the customers come up to you and say, look, I want to do this, I want to do that, and you don't want to write a custom implementation for things every time. In Elasticsearch, a common use case is that we have a feature called so-called ingest processes, where you can modify the JSON before it gets indexed. And imagine someone indexes a document which has a bytes in field and a bytes out field, and you want to have a bytes total field. So one way you could tell your customer is always like, oh yeah, that's not a problem, you can just write your own plugin and you have to maintain it to eternity just for adding up 2 fields. This is quite the overhead. Or use one of our custom scripting engines where you can just add those 2 fields and store it in a 3rd field in the document. And scripting is used at a couple of places, but that's the whole idea, right? Scripting is basically a shortcut so that the users of your platform don't have to write too much code themselves, and yet it should be super, super flexible. So scripting has been in Elasticsearch since ever. When I started, or when I did my first Elasticsearch installation more than 8 years ago at my former employer, I basically played around with MVL. MVL is MV expression language something that you may know from fun things like JSP. And this was a nice thing, it worked, but it was not really maintained, so it was pretty tedious to keep up. And at some point we found out about Groovy. Groovy is also a JVM-based programming language, a bit more script-like with a lot of shortcuts. And a sandbox. So Groovy had a security feature. You could have a sandbox. You could also use black or white listing of classes being loaded or not. So it was a good idea. We added Groovy as our default scripting language. At some point we got an email from someone from a rather big corporation who wrote us like, if I do this and this and this and this and this and this and this, the sandbox doesn't exist anymore. So he was able to execute code. This was before we also added the Java Security Manager to Elasticsearch. So we sat down and fixed the problem, but we also thought like, what are we gonna do next? You have 2 possibilities here, right? First, we talked to the Groovy developers who were more like, this is not a bug, this is a feature, and from their perspective it made sense. They just intended this whole idea of how we used the sandbox feature in a very different way than what we did. And you could also start now to always close security holes that have been found, right? You could play the famous whack-a-mole game. You fix one security hole in your Groovy scripting engine, a new one pops up, and you do this all the time. So you're always running behind. And one other issue is this means that your scripting implementation will never be faster than the initial Groovy implementation. And we wanted to have faster scripting. And there was already a scripting engine called Expressions in Lucene, which was really, really small, really, really simple, which basically compiled to Java bytecode in memory and executed this bytecode, so it was really fast. And we basically extended the scope to cover all of our use cases, and this is how the painless scripting language basically came to life. And the main idea of this was that painless was also sandboxed, like Groovy was, but we, of course, had full control over the sandbox because we wrote it. That we have whitelisting over blacklisting, but on a per method base. The old Groovy sandbox only allowed white and blacklisting on a per class base, but there are always some not so nice static methods like on the string class or wherever where we really don't want this to be executed. So this is just more granular. Also, regular expressions are a bad thing, right? Like we all have this famous moments where we try to debug a customer's problem and he just copy-pasted this fancy regular expression from Stack Overflow and suddenly you have one CPU constantly running against this regular expression. And this is something you really don't want if you don't have to. So we basically made regular expressions a configuration flag. By default, they are disabled because speed is really important to us. Also, if you have your own scripting language running for your customers, do you think about things like preventing endless loop? Like what happens when one of your customers is running while true do something? Like are you just clocking one CPU and you're hoping you have still enough others available? If you control the sandbox and the execution environment, you can just abort this kind of runs after, I don't know, 10,000 execution and say, okay, this ran too long, I'm exiting. The same for detecting self-references. If you have two maps which are referencing to each other and you're calling toString on them in Java, you get a Stack Overflow exception and the JVM stops. This is easy to detect actually in your code, but you have to do it. And I don't want my customers to be able to kill my process. And this is all the kind of things which we basically put into thought when coming up with Painless. So this is a summary. I have a couple of bonus slides and I still have 10 minutes left, which is good. My summary is first, of course, arguing a little bit. We have a couple of Java people here. No one is using Security Manager. So what's your excuse? You get a lot of features or a lot of additional security for free. So I really urge you to take a look at it, especially if you're running either in secure environments or if you have kind of a big attack surface because your product is running a couple of 100,000 times on the internet. I think it makes a lot of sense to think about those things. Scripting is important. I don't think we could live without scripting in Elasticsearch. It's a great feature. But did you really test your application or your scripting implementation against certain things? And please, please, please do not rewrite security features of the operating system in your own code. This is always going to fail. There are always people who are smarter than you. This stuff like Seccomp, it's been there. It's been there for years. It's really well battle tested. If you try to write your own engine which tries to find out if someone passed a string over an HTTP request that seems to execute some code, you will always lose this battle over time. So if you can, just make sure you take a look at your operating system and what kind of features you can use. Also, if you don't need plugins, don't even think about supporting them. Don't even think about let other users run code in your system. On the other hand, plugins are super powerful, but think about security. Also think about stability. If you're a Java application and you don't have this class loader separation, then one person which has a different Java version in the plugin may be able to crash your whole system when you're running. Think about Guava, for example. Guava is kind of a dependency in, I don't know, 80% of the product, so you have to be super careful there. And one last bit, if you remove features, have alternatives, but don't be afraid to remove features. And this is something I want to quickly talk about. We have a couple of minutes left. I will publish the slides later on, so you can take a look. I have two topics I want to talk further about, and the first one is deep pagination. Any one of you ever wondered why you can't reach the last page of search results on Google? Because searching on distributed systems can be hard. Let's take a look at this. We have a node and we have a client. And the node asks for the first 10 results searching for Elasticsearch. This is a simple thing, right? We go to the node is searching in its data, is, okay, these are my first 10 results. Node goes back to the client is happy, goes away. Imagine you're running the same search on 5 nodes. What happens? Each of those 5 nodes have to come back with their personal top 10. And then you have 50 results on the coordinator, and he has to create a real top 10 out of that. And then he has to go back to the original nodes, which contain those real top 10 data, and then return this to the client. So you basically have a two-phase search in there. And the sorted priority queue suddenly has a size of 50. 50 is maintainable, you just need to sort by score, whatever, it's doable. Let's imagine we are trying to find the same search, but we want to start at position 90. So we don't want to get the top 10. Imagine we page through a couple of pages and we want to get the results from 90 to 100. This basically means we have to get the first 100 results of each of the nodes only to find the real 90 to 100. So suddenly your sorted priority queue has a size of 500. That's still doable. Let's play this a bit further. Let's imagine you want to go from position 990,990 to 100,000. This basically means you have to get the top 100,000 each back and then extract the next thing. You can see where this is going. The sorted priority queue can become big. And this is only a single search operation. Imagine that you're running a couple of thousand search operations per second. You will need a lot of memory for this. So if you have 100 nodes instead, you would have a sorted priority queue of 10 million. So this is getting big pretty fast. And this is the reason why you can't go to the last page of Google results. This is also the reason why maybe your search engine is getting slow over time, because humans, they don't page through 100,000 pages. but spiders on the web do. And the moment you expose Elasticsearch via any API or any search, it means that this one spider or this 100, because the web is big nowadays, which will try to go to the last page if you offer this functionality. And this means that you will need to have the resources. What can you do? You can use search after. So we had this deep pagination for a long time as a single feature, but at some point, a couple of companies came up to us and said, like, this doesn't work, this doesn't scale, it eats a lot of memory, we have out-of-memory exceptions because of this. So we thought, how else could we implement this? And the idea was, instead of using numerical positions, like starting at offset 990,000 or something, we basically use the keys which are in the data structure which is being used. So basically, the client should tell us where it stopped, and we pick it up there again. The advantage of this solution would be that we offload some state to the client comes back to us, and the idea of this is that because we know where to start when we page to our results, we only need to get 10 results from each of the nodes, because each of the nodes suddenly knows where to start. And this functionality is basically called search after, because the client is telling Elasticsearch, only start returning results after this information that you supplied. And the nice idea of this is, even if we run across 100 nodes, no matter how deep you're paginating, the sorted priority queue will always have a size of 1,000. Okay, still 5 minutes, which means the second bonus is able to go through. I want to talk about a little bit, which is also a couple of years back, but I think it's important because sometimes you have to remove features which are really convenient for users. And your users are going to hate you for that. And this was the case with the delete by query API in Elasticsearch. Delete by query is a super nice feature where you can basically specify a query, and all documents matching this query are deleted. I guess it's kind of obvious by the name. But we found out this API was not as safe as we thought it was. So Elasticsearch has a notion of a shard, and it can contain has copies of those shards across a cluster. And our assumption is always that if you have one shard and there's a copy, they contain identical documents. And even if you have 10 of those copies, they should contain identical documents. Well, it turns out this API could basically delete or remove this assumption, and you could run out of sync with those shards. So what we did is we removed this API endpoint because it was not safe. We wrote extensive documentation what you can do instead, so you could remodel this exact same functionality on the client side by implementing a bit more, by programming this out yourself, which of course was the reason why our users were not happy. We basically removed the convenience function and said to them, please do it yourself. Yes, this is a bad thing. We absolutely knew that, but we said like the safety of our data is more important. And in order to fix this, we needed some infrastructure first. So delete by query is a process that if you run it against 10 indices and each of them has 5 billion documents, this can take a lot of time. And Elasticsearch back then did not have the infrastructure to have long-running tasks in the background. In order to have this feature, we had to add this infrastructure first. And then we basically reintroduced delete by query by doing exactly the same thing that we stated in the documentation for our users, just by implementing it ourselves. And this was basically the way to make delete by query work again. And for us in this case, the safety and the reliability of the data was just 100 times more important than the convenience for the user, despite that we knew that users are going to be unhappy. I just want to say, if you write your own applications, if you have your own customers, which is super likely, otherwise you don't get money, sometimes you have to take a bad decision, but you have to have a path how to fix this. Maybe not immediately, but give your users some sort of confidence that there's a possibility to fix this in the long run. And it also took us a whole major version to create the backend infrastructure. But I think it's super important to keep that in mind. Okay, I think I'm pretty much out of time. Do we have time or not for one question, if there are some? Yeah. Okay, so if there's a question, 5 minutes. Okay, we have plenty of time apparently. If there's a question, we're open for it. I also have a second talk tomorrow, so if you're interested in how we test and release the Elastic Stack and how we test Elasticsearch, and I can talk a little bit about CI and releasing it, and what happens before you can read on our website that there's a new version of Elasticsearch out, I think it's at 11 a.m., so right before lunch. You're not going to be as tired as you are now. Please come by, and apart from that, thanks a lot for listening, and if you have questions, go ahead. Awesome. No? Lunch tiredness. Question?
Thanks for your talk, and my question is, maybe I missed something in documentation, but do you have inside documentation something like best practices or maybe some scripts or checklists for to allow you to make your initial setup of Elasticsearch more safer?
Safe as in security or safe as in?
From the security perspective.
Okay. I don't think we have a ton of documentation, but the whole idea from an Elasticsearch perspective is basically that there's not so much to care about. I think the biggest thing is encryption of data, and this is part of our commercial offering. So if you would look it up there, we show you how to set it up, including authentication and authorization. Apart from that, most of the stuff I talked about today is all part of the default setup. Like the security manager is enabled by default. You can't disable it because we don't want you to fiddle around with it. So all of these things I talked about today, they just come included. And the other parts where you can think about things like permissions for files, for example, to make sure you don't leak credentials in configuration files. If you use the packages like RPM or Debian package, they always contain the right permissions. But if you ship it yourself, like with Puppet, Chef, or other things, it makes sense to check those for yourself to make sure you don't accidentally use permissions where everyone can read a file, for example.